Howdy apes. So I'm not there today. My daughter came down with strep, so you are getting me in video form instead. We are going to go over some of the basics for population math because it's always good to continue on with your notes even when I am not around. So you are going to need some paper. Scratch paper is just fine. You are going to need a calculator. So you can use your phone if you want. That's just fine. You're not going to be doing some heavy duty calculations, but make sure that you are ready to go and we will get started. All right. When I say these are formulas to know, that means I want you to memorize them. And do it now. Do it right now, because this is probably the only time you're going to see all of these all on one page. You're not going to get a formula sheet on the test, not on the APES test, not on my test, not on my quizzes. So please make sure that you know what these formulas are, and we're just going to practice how to use them today. I'll go through each one of these individually when we get to use them. But for right now, this is just like your quick little cheat sheet on what you need to know, and make sure that you do commit them to memory. All right, let's go ahead and start out. We're going to start with population density. Now, these calculations are not difficult. I'll say that right up front. Your formula is simply a division problem. Number of individuals per given area. So given area meaning meters squared or acres, something like that. Number of individuals is how many are in there. So you count them up. It's really as simple as that. However, sometimes reading through your problem will get you a little bit confused, and you have to shuffle this around and everything. And I also want to make sure that I give you examples on how I want to see your work being shown. Even though you do have a calculator, you still do have to show your work. So let's look at this first problem. What is the population density of a country where 720 million individuals occupy a region of 500 million square kilometers? So our 720 million individuals, that's our number of individuals, and 500 million square kilometers, that is our area. So we already know we're going to divide 720 million by 500 million square kilometers, and it's going to give us our answer. That's easy, but you need to show where that came from. So we're going to come over here and say population density equals 720 million individuals. Okay, those could be bears, those could be rats, those could be bacteria, whatever they are, divided by your area. So they live in 500 million kilometers squared. All right. So I set it up like this so that I can show that I'm going to simplify this, basically. Now I could have written out 720 and shown 720 million. But writing this out in words actually makes it a little bit easier. So if we were doing this fully by hand, I would just cancel that out. I would probably cancel out my zeros as well, and I'd end up with 72 individuals per 50 square kilometers. Okay? So now put it into my calculator. 72 divided by 50, and that gives me 1.44 individuals per kilometer square. And there's your answer. So make sure that you are showing all of this work. It's not just enough to say, hey, I know the answer is 1.44. It's where did this come from? And make sure that you know how to show that on your paper. All right, let's go. Now your turn. You're to work this out. You can pause this, you can do whatever you like, but I want to see number 1 tomorrow. There are going to be a couple of your turn problems on here, so you're going to show me how you did number 1 in the way that we just showed this. So you're going to show me all of your work and show that you know how to do this. All right? This is straight population density, and you can do it. All right, let's move on. Calculating population size. So your formula for population size has initial population, that's what this I is for. Initial population plus births plus immigrants minus deaths plus emigrants. So basically, you have everything that is being added to your population minus everything that is being subtracted from your population. So here's our problem. In here, we have a population of a town of 400. That's your pop I.
Okay.
And there's my daughter. She's decided to come into the recording. That experiences 40 births and 20 deaths within a given year. So I'm going to box what is coming in. Remember, this is plus, and 20 deaths, we're going to put a circle around what leaves. 20 deaths. Nice. All right. And then we also have to consider immigration. So 12 people have moved in, so they're being added. Okay, you can have that, sweetie. And 4 people are leaving. Those are our immigrants. All right, now let's set this up. Population size equals our initial population, 400 people plus. Now in your births and immigrants and everything, you do not have to label those. So births, 40, plus immigrants, 12, minus deaths, which were 20, plus immigrants, 4. There we go. So now all we have to do is combine 400 people plus 40 plus 12 is 52, and 20 plus 4 is 24. 52 minus 24 is 28. So 400 people plus 28 equals 428 people. So our population size is 428 people. There you go. And that's it. All right, so now you have your turn. Pause this if you need to. You're going to solve this in just the way that we solved this before. Show all your work like we did before, and you'll add this on to number 1 and show me tomorrow. Next. Growth rate of a population. Now we have several different ways to calculate growth rate. This is our first one right here. So it includes our birth plus immigrants minus deaths plus emigrants and our population size. We turn it into a percent by multiplying it by 100 here at the end because it's a rate. So we are going to calculate the growth rate of a town of 400. And we have the same parameters as before. So same original population size. We've got the same number of births. I'm going to box those again. And deaths. So this is added. This is subtracted. We've got the same number moved in. This must be the same town. And the same people moved away. All right. So if we set this up, growth rate, GR, equals our births plus immigrants minus deaths plus emigrants, which we already calculated was 28. Remember from our previous example? So I'm going to skip that step. You would have to put it in, but just for our, just right now, Lily. There you go. Sometimes we have interruptions from the peanut gallery, aka child with strep throat. All right, so remember that you're going to need to show this information right here. But for right now, just for expedience, we're going to say that we've already done that. So 28 divided by our population size, which is 400 people, times 100. So we're going to take this whole thing right here and multiply it by 100. So we can enter that into our calculator. 28 divided by 400 equals 0.07 times 100. When we multiply this by 100, we simply move our decimal point over to the right, and we get 7%. All right, so we have a 7% increase in that population size per year. All right, now guess what you get to do? Your turn. All right, same formula, same everything. I want your answer to round to the nearest whole number. Show me tomorrow on that same page, number 1, number 2, and number 3. All right, rule of 70. Rule of 70 we also call calculating doubling time. So this is how much time it would take for your population to double in size. All right, doubling time equals 70. We always use this number, 70. That's why it's called the rule of 70. Okay, 70 divided by your growth rate. So this is where we actually use our percent, and we just take the percent and we go and forget that sign. So for instance, if we take our 95% growth rate, and we want to figure out how much time is it going to take for that population to double, then we just say, oh well, and we put in the 95 right here as our growth rate. Okay, we do not, for instance, take that and move it over and make it a decimal. No. Don't do that. All right, make sure to always take it as a percent and just completely plug it in. All right, so we're going to take the same town that we did last time, our same town. If you were seeing this for the very first time, you would first have to calculate growth rate. But since we already calculated growth rate, we know that our growth rate is 7%. So we can go straight to doubling time. So doubling time equals 70 divided by our growth rate. And remember, growth rate is simply this. We're simply going to go, oh, no, forget about that percentage, and plug in 7 right here. All right, 70 divided by 7. All right, so 70 divided by 7, hopefully you don't need a calculator for this, equals 10. And the doubling time is in years. This formula is so simple.